Factoring a trinomial with a leading coefficient of 1. These are considered to be easier trinomials to factor, and you'll understand that when we get to the more difficult ones. Okay, so first of all, what is a trinomial? A trinomial is a polynomial that consists of 3 terms. And when we get ready to factor a trinomial, we need to get it in the right order. It needs to be in descending order according to the exponents. And so when we're factoring a trinomial, it should look something like this, where we have the biggest exponent first. So this has x squared x and then the constant. Now, whenever we factor a trinomial, we have to think backwards of foiling. So remember, foiling is how we multiply 2 binomials together, or a method that can be used to multiply 2 binomials together. And so we're just kind of going to go backwards from that. So we ask ourselves, what terms do we need to multiply to get the first term? What terms do we multiply to get the last term? And then what terms do we add or subtract to get the middle 2 terms, the outer and the inner terms? All right, so let's factor a trinomial. Let's look at number 1. First of all, is it in the right order? Yes, it's going from greatest to smallest according to the exponents. Okay, and we know that our answer is going to be in the form of 2 binomials, so I'm going to go ahead and put my 2 sets of parentheses, and then I'm going to fill them in. So I ask myself, what do I need to multiply together to get this first term? Well, the only thing that I can multiply together to get x squared would be x and x. So that's what I'm going to put in the first 2 spots here in my binomials. Okay, then I'm going to fill in my signs. So these are binomials, so I'm going to have a term, a plus or minus, and a term. A term, a plus or minus, and a term. Okay, so I'm going to put my plus and minus signs in. Well, I'm going to look at this second sign first. If that sign is plus, then that means that my signs in my binomials are going to be the same. If my sign is minus, then they're going to be different. Okay, so since this is plus, I know these are both going to be the same. Now, I'll look at my first sign in my trinomial to tell me what they are. Okay, so they're both pluses. Okay, and then to fill in my last 2 spots, I need to find what would multiply to give me 6. And then since my signs are the same, since I'm adding, what will add together to give me 5. Okay, so let's think about what the factors of 6 are. So the factors of 6 would be 1 times 6 or 2 times 3. So which ones of these would add together to give me 5? 2 and 3. Okay, so that's what I'm going to put into my 2 binomials. 2 and 3. Now, the way that we check, so remember, anytime we're factoring, we should always be able to check our answer. So this would be my answer. Check my answer to see if when I multiply it back together, it should be what I started with. So I'm going to multiply these back together. So if I multiply these back together to check it, well, I know that the first 2 are going to multiply to give me this first term. X times x is x squared. I know the last 2 are going to multiply to give me 6. The ones that we really have to worry about are the inner and the outer, because that's where the mistakes happen. So what I say is make a smiley face. This looks like a nose, and then this looks like a mouth to me. All right, so my nose part, positive 2 times x would give me a positive 2x. And then x times positive 3 would give me a 3x. And if I put those together, I get 5x. And that's what I need it to be for that middle term. So I know that I factored it correctly. Always check your answers when you're factoring. So this is my answer. Now, of course, if I had x plus 3 times x plus 2, That would be okay too. As long as the stuff inside the groups are the same, it doesn't matter what order the groups are in. Let's look at number 2. Again, I know that I'm going to have 2 sets of parentheses in my answer, so let me go ahead and put those there. What can I multiply together to get this first term? X and x. Then I look here to tell if my signs are the same or different. They're the same because that's a plus sign. So now I look at the first sign to tell what they are. They're the same, but this time they're both negative. Okay, so my signs are the same. This is a plus sign, so that's telling me that I'm still going to be adding these two together to get my middle term. So which factors of 6 would add together to give me 5? 2 and 3, or 3 and 2. It doesn't matter what order. This time I'll just put 3 and 2 just to change it up and show you that it doesn't matter. Okay, so remember we double check it by making a smiley face. I know that my first 2 terms give me the x squared and my last 2 terms give me 6, but let's double check for the middle term. That's a negative 3x, and that's a negative 2x, which would be a negative 5x. Is that what my middle term is? Yep, it's a negative 5x, so I know I factored it correctly. Okay, so that's my answer. Okay, number 3, 2 sets of parentheses. What's going to go in the first 2 spots? X and x. Okay, now when I look here, I know that my signs are different. So I know I'm going to have 1 plus and 1 minus. Okay, since my signs are different, I'm going to need the factors of 6 that will subtract. This is subtraction to give me 5. So which one of these would subtract to give me 5? 1 and 6 this time, right? Okay, so I know they're going to be 1 and 6. Now I'll look at the first sign, and this tells me the sign of the bigger factor. Okay, so bigger. So the bigger number between 1 and 6 is 6. So that means this tells me the 6 needs to be positive, and then the 1 would be negative. Let me move this parenthesis in a little bit. Okay, so let's double check this. I know the first 2, if I multiply those 2 together, I get x squared. If I multiply these together, I get 6, but let's check to see if I get my middle term. Make a smiley face. That's a positive 6x, and then this would be a negative 1x, which would give me a positive 5x. And that's what I need it to be. So I know that that's correct. Okay, number 4, 2 sets of parentheses. What goes in the first 2 spots? X and x. This tells me my signs are different, but this time the bigger term needs to be negative. Okay, again, I'm subtracting, so the factors of 6 that would subtract to give me 5 are 1 and 6, but this time 6, the bigger number, needs to be negative, and then the 1 is positive. Okay, so let's check by doing our smiley face. And if I multiply the inner 2, I get a positive 1x. And the outer 2 will give me a negative 6x, which would be a negative 5x. And that's what I need it to be. Alright, so all of these we're using the same numbers. So let's try one with some different numbers. Let's look at number 5. Okay, in number 5, again, if I do the 2 sets of parentheses, let me scroll down a little bit. Same thing's going to go in my first 2 spots. Anytime I have a variable squared, and that's why these are called the easier trinomials to factor. I know in the first 2 spots I'm going to get whatever that variable is, or the square root of whatever that variable is. Okay, so now I'll look at this sign. And this tells me that my signs are going to be what? The same. And then this tells me that they're both plus. Now, 24 has several factors. We could multiply 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So we need the factors of 24 that will add to give me 11. Which ones will add to give me 11? 8 and 3. Okay, now since they're both the same, it doesn't matter which order we put them in. We could put 3 here and 8 here, or we could put 8 here and 3 here. It doesn't matter because they're both positive. And then if we check them by making our smiley face, this is positive 3x. This is a positive 8x, which gives me a positive 11x. All right, here, 2 sets of parentheses, x and x. My signs are the same, and they're both negative. So for 8, we have the factors of 1 and 8, or 2 and 4. Okay, so I'm adding again. So which ones would add to give me 6? 2 and 4. Again, it doesn't matter what order because they both have the same sign. And if I check it, I get negative 2x, negative 4x, which adds to give me a negative 6x. All right, for number 7, 2 sets of parentheses, x and x. What are my signs? They're the same and they're both positive. Okay, so for 4, the factors are 1 and 4. I recommend always writing out what all the factors are so you don't miss any. If you start with if you start with 1 and go up until they start repeating, then you know you have all the factors. So what factors of 4 would add to give me 4? 2 and 2. And if I check these, this would give me a positive 2x and a positive 2x, which gives me a positive 4x, and that's what I need it to be. So for this one, if you'll notice, it's x plus 2 and x plus 2. So you could write your answer like that, or you could say that this is x plus 2 squared. It doesn't matter. Okay, for number 8, 2 sets of parentheses, x and x. Are my signs the same or different? This tells me they're different. Okay, now for 18, we have 1 and 18, 2 and 9, and then we have 3 and 6. And then that's it. Okay, so which factors would subtract to give me 7? 2 and 9. And then remember, this tells me the sign of which one? The bigger number. So the bigger number, 9, needs to be negative. The 2 is positive. So if I check this, that's a positive 2x and a negative 9x, which would give me a negative 7x. And that's what I wanted, a negative 7x. So if you checked it and you got a positive 7x, then you know you put the wrong sign, or the numbers with the wrong sign. Now, no matter what type of polynomial you're factoring, you should always check for a GCF first. So if I look here at number 9, do I see something that they all have in common? Well, this is a negative 1, a 2, and a 15, so you might say, no, they don't have anything in common. But anytime this leading coefficient is not 1, it's going to make it a little harder to factor. So an easy trick when you're factoring is to turn it into a positive 1, and the way you do that is by factoring out a negative 1. So that's what I'm going to do. I'm going to factor out a negative 1. So that means if I'm factoring out a greatest common factor of negative 1, all that's going to do is just change the signs of all of these terms. So this is going to become a positive x squared, negative 2x, and negative 15. And now that's turned this into an easy trinomial. When we factor out a greatest common factor, we don't just get rid of that. That has to tag along with our answer, because remember, we should always be able to multiply our answer back together and get what we started with. And if I just get rid of that negative 1, I'll never get back to where I started. So it just tags along, and then now we have this easy trinomial that will factor into 2 sets of parentheses, x and x. Here, my sign, so we don't go back to the top, we go to this step right before it. This is a negative, so that means that these signs are different. Then the factors of 15 are 1 and 15, and 3 and 5. So which ones will subtract to give me 2? 3 and 5. Okay, what does the sign of my bigger number need to be? Well, I look here to tell, and it should be negative. Okay, so now to check this, this gives me a positive 3x and a negative 5x, which would be negative 2x, and that's what it was here. Okay, so that's where it came from. And then if I multiply it by a negative 1, that becomes the positive 2x. So my answer is this whole thing. So it's the 2 binomials and that negative 1 also in the answer. Okay, for number 10, is there a greatest common factor between all 3 of these terms? Yes, all of these terms are divisible by 6. So if I divide each term by 6, this is what I'm left with. And then, now like I said, that's got to tag along with my answer. Okay, so then I get x and x. Now, what are the only factors of 3? Oh, well, let's fill in our signs first. So this tells me my signs are the same, and this tells me what they are, so they're both plus. Okay, then the only factors of 3 are 3 and 1. So 1 and 3, 3 and 1, it doesn't matter what order. So we know that that's got to be what goes in those spots. And then we can check it by doing our smiley face. This would be a positive 1x, a positive 3x, which gives me the positive 4x that I need it to be. So this is all of this with the 6 is my answer. What does number 11 have in common? Well, as far as numbers go, I don't see anything, but they do all have an x. So if it's something they all have in common, we can factor it out. And if I divide each term by x, that's just going to reduce it by one variable, by one exponent. All right, and so then that would be 10x, then plus 24. Okay, so the x just tags along. And I have x, and my signs, this tells me my signs are the same, but this time they're both negative. Okay, so for 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so which one of these would add to give me 10? 4 and 6. And again, since both of these signs are the same, it doesn't matter which order we put it in. And then we can double check it, and this is our answer. Now, I just wanted to show you one more little thing. If you had something like this, and you were told to factor it, so say I did my x and x, and then this tells me my signs are different. Okay, so the only factors of 5 are 5 and 1. Okay, so no matter which place I put 5 in, if I subtract 1 from 5, I'm going to get 4. I'm not going to get 3. So there's no way this will work. Well, just like the number 3 or the number 5, those are called what kind of numbers? Prime numbers, because they're not factorable. If we have a polynomial that can't be factored, we say that it is prime.